Welcome to my video on 6-2A, Introduction to Sequences. Today we're going to discuss what a sequence is and some vocabulary words that are associated with it. So to start us off, I'm going to ask that you look at the do now, which asks you to find the next number in the pattern below. So there are two patterns here. This is the first one, and this is the second one. Something different is happening in each one of those. So when we're looking at patterns, right, we want to see what the relationship is from one number to the next. So how do we get from 43 to 32, from 32 to 21, and is that the same thing happening every time? So if we look at those two numbers, it doesn't look like the numbers are changing significantly. Okay, so typically the first thing I always check is, can I just add a number or subtract a number to get from one to the other? So if we look from 43 to 32, we see that if we subtract 11, we would get from one to the other. Now, if that is the same for the next couple of terms, we know that we have a pattern here. So 32 minus 11, is it 21? And it is. Minus 11, is that 10? It is. Minus 11, correct. Minus 11. So the pattern here is subtracting 11 from the term before it. So if I wanted to find the next number in the pattern, I take minus 12, minus 11, and I get negative 23. So that's the first pattern. Now we take a look at the second pattern, 15, 45, 135, 405. Now something you should notice here is that the numbers change significantly from one to the next, right? We go from small numbers like 15 and 45 to big numbers like 405 rather quickly. So typically when that happens, I try to see, is there something being multiplied here? Or if the number started big and went small, is there a number being divided? Well, we know that 15 times 3 is 45. Well, 45 times 3 is 135. And 135 times 3 is 405. So we see a pattern here of multiplying by 3. So if I take this last term of 405 and multiply it by 3, I see that the next term is 1,215. So what we are looking at here is called a sequence. Okay, a sequence is an ordered list of numbers. In general, these terms could be anything, but we're going to be primarily looking at them with numbers. And each number in this ordered list is called a term. Okay, so the first number in the first position is called our first term, and that's its place in line. So we cannot switch terms out of order. They have to be in how they are given to you at the start of the question. Now, each term is named by its position. So as an example, I have here, right, our first term is going to be called A sub 1, right? It's A with a little 1 attached to it. Our second term would be called A sub 2, an A with a little 2 attached to it. Now, notice that is not a exponent, but what we call a subscript. Okay, the difference is that the subscript is at the bottom, and in general, a subscript tells you the name of something, not like an exponent where we have a mathematical operation associated with it. Now, this notation that we see up here, once we get past third, fourth, fifth term, we might start talking about general terms, like what happens way down the line. So typically we call that the nth term. What happens at the nth term? We're not giving it a specific name, but we know that it's just a general term of the sequence. Now, something you'll see when we define our sequences is that we will base off other terms from this nth term. So the term that goes before the nth term would be A sub n minus 1. Why? Because we would take the number n and subtract 1. Just like the number in front of A sub 3 is A sub 3 minus 1, which is 2. The term that comes directly after the nth term, we call it A sub n plus 1, right? Because we are adding 1. So just like A sub 2, the next term is A sub 3, is 2 plus 1, we can just leave it in a general form. So if we look at this ordered numbers, we have 2, 4, 6, 8, 10. That's the sequence of numbers that we're looking at. We would say 2 is A sub 1, 4 is a sub 2 because it's second in line. 6 is a sub 3 because it's third in line. 8 is a sub 4 because it's fourth in line, making 10 a sub 5. Okay. So if we wanted to know a general term, right, we can keep going till a sub n, any number down the line. So the first way we're going to define these sequences is by something called a recursive formula. Okay, so a recursive formula is basically a rule that allows you to find a given term based off the term before it. Okay, so just like we had in the do now, we started with 43. There was no reason to just start with 43. We were just given that. But we were able to find every term after it by subtracting 11. Well, that would be something we would create a recursive formula for. Okay, now the recursive formula always has two parts. It has what we call an initial condition, or the first term, right, the one that is defined, and a rule based off of the previous term. So as an example, I have 133, 130, 127, 124. Hopefully you see that this is subtracting 3 from one term to the other. But we are starting with this 133, so just a random number. So the recursive definition, or the recursive formula, has the two parts. A sub 1, which is our first term of 133, and then a sub n, which is just any general term, is found by taking the term before it, a sub n minus 1, and subtracting 3. Okay, so if I wanted to see how this works, right? If I wanted a sub 2, well, really, what am I doing? I would take a sub 2 minus 1 and subtract 3. Well, 2 minus 1 is a 1. So for the second term, I would take the first term and subtract 3. Is that how we got our second term? Yes, it does. Does it work for the next one? Let's try it. A sub 3, we want the term before it. And subtracting 3. 130 minus 3, is that the 127? Yes, so this is a good recursive definition. Okay, so let's write a recursive formula for each of the following sequences. So we're going from 7 to 3, 3 to -1, -1 to -5. What is our pattern there? Well, we're getting from bigger to smaller, so we're either multiplying or dividing. In this case, we will be subtracting 4 from term to term. So what do we need for our recursive formula? Well, we need a sub 1, the first term, 7. Now we need a rule to calculate all the terms after this. So what's the rule asking? It's asking for a sub n, any general term. We're going to take the term before it, a sub n minus 1, and subtract 4. Okay, so remember, this minus 4 does not have anything to do with the subscript. That subscript's attached to the a. So that would be our recursive formula. What about the next one? 1 to 3, 3 to 9, 9 to 27. Hopefully you see that that's times 3. Okay, so if we're writing a recursive formula for this, we need our first term, which is 1, and then a rule to find a general term based off of the term before it. So what am I doing to the term before it? I am multiplying it by 3. You will often see that as a sub n 3 times a sub n minus 1. So we can actually move this over. And that would be the answer you would typically see on a multiple choice. Okay, so now my question to you is, what is the difference between these two different sequences? Right, we can write a recursive formula for them. They have ordered lists, but what's different about them? Well, this one is subtraction. This one is multiplication. Those two types of sequences are going to have very different names.